Solving simple trigonometric equations. Quite often in Core 2 you'll be asked to solve trigonometric equations between a certain range for a trig ratio. For example, you could be asked to find all possible values for a cosine problem between the values of 0 degrees and 360 degrees. It's also really important to make sure that you've got your calculator set up in the right units. So if you're asked to find a range in degrees, make sure you've got your calculator set up for degrees. And if you're asked to find the answers in radians, make sure you've got your calculator set up in radians. But it's quite easy to lose marks by having your calculator set up in the wrong mode. Now this video is just going to show us a couple of easy examples of finding the solutions to a problem. Now the question we've been given here is solve 5 cos x equals 2 between the values of 0 degrees and 360 degrees. Now this means we need to make sure we have our calculator set up in degrees. So first thing to do at this stage is to do that. So that will probably be indicated by having either DEG for degrees on your calculator in the display box or just a letter D. And likewise for radians it will probably say R or RAD for radians. So first thing to do with our equation 5 cos x equals 2 is to rearrange this so we've just left with cos x on its own. So what we need to do here is to divide both sides by 5 to leave us with cos x equals 2/5. And to find out what the angle is, pick up your calculator and do cos to the minus 1 of 2/5. Which if you do, you get the answer x equals 66.4 degrees. Now we're asked to find all the solutions between 0 and 360 degrees. Now the easiest way to find all the solutions is to quickly sketch out the trig function that you're using. So we're using cosine. So that we know starts at 1 at 0, goes through at 0 at 90, at 180 degrees it'll be at minus 1, at 270 back at 0, and 360 it'll be back up to 1. So it's going to curve like that. So our two solutions to this problem, we've already got our 66 degrees, which is in this region, but we've also going to have one in this region over here. Now it's 66.4 degrees away from 0. So it's also going to be 66.4 degrees away from 360. So to find the second solution, we need to do 360 degrees minus what we're given on the calculator, 66.4, and you get the answer 293.6 degrees. So those are your two solutions in the region of 0 and 360 degrees. Now this second question, we're asked to solve 4 sine theta equals root 7 of cos theta between minus pi and pi. Now this means that we are using radians, so at this point you need to convert your calculator from degrees to radians and give your solution in radians. Now your first initial problem in this question is that the fact that you're given sine thetas and cos thetas. Now you should remember from the trig identity video that the relationship between sine theta and cos theta is that if you do sine theta divided by cos theta, you end up with tan theta. So in this question here, we need to make sure that we're working in one trigonometric ratio, and this one will be tan. So we're going to start off with our equation 4 sine theta equals root 7 cos theta, and we need to divide both sides by cos theta. So we're going to have 4 sine theta divided by cos theta is equal to root 7. Now as stated over here, tan theta is equal to sine theta divided by cos theta. So our sine theta and cos theta here, we're going to now simplify to make 4 tan theta equals root 7. Now if we divide both sides by 4, we're going to be left with tan theta is equal to root 7 over 4. And provided you've got your calculator set up in radians and you do tan to the minus 1 of root 7 over 4, you'll get the answer 0.584. Now remember, we're asked to find all the solutions between minus pi and pi. So like we did with the cosine one, we need to sketch ourselves the tan graph between pi and minus pi. So minus pi, pi over 2, 0, pi over 2, and pi. And it goes up there. It's got an asymptote at pi, pi over 2, and it's also got one at minus pi over 2. And it'll go like that. And the solution that we found is going to be in this region here, because 0.584 is less than pi over 2, so it's in this region here. So there's also going to be a solution in this region here, which will be minus pi, add on, and 0.584. So the final step to do is minus pi, add on the 0.584, and we'll get our second solution to the problem, which is minus 2.557. So remember to find all the solutions in a given range, and to make sure that you're using correct trigonometric, the correct measure for angles, either degrees or radians.